So anytime that you have data that has a normal distribution, we said that we can use a measure of center such as the mean or the median to describe the typical value for our data set. But using just the mean or the median to describe that typical value, it doesn't give us the big picture or the whole picture. So we have to also talk about measures of variation. So how does our data vary relative to the mean? Because if we just talk about the mean alone, again, it doesn't give us the whole picture. And here's an example of what I mean. So on the left here, I've got a distribution for daily maximum temperatures for the city of Provo, which is in Utah. And on the right, I've got the daily maximum temperatures for San Francisco, which is in California, and it's along the Pacific coast. So hopefully you can see that both distributions are approximately normal. So they have the same shape, they have that bell shape, where we'll be able to find the mean at the center of the distribution. So if we calculate the mean, or visually, if we look at the mean for each city, we can see that they're kind of close to each other. So for Provo, that mean temperature is around 67 degrees Fahrenheit. And for San Francisco, that mean temperature is around 65 degrees Fahrenheit. So both cities have a mean temperature that's really close to each other. So the typical temperature for Provo and San Francisco are similar. But we can see visually from the histogram of each city's temperatures that how the daily temperatures vary, that variation in temperature is a lot different for Provo compared to San Francisco. So if we take a look at how we measure variability, the range or the horizontal spread of our distribution is a very informal way of describing that variation. So hopefully you can see that in San Francisco, that spread in temperatures is a lot wider than the spread in temperatures for San Francisco. So informally, we can say that Provo, its temperatures varies a lot more than in San Francisco. In fact, if we look more closely here, we can see that in San Francisco, most days the temperature is very close to the mean. Okay, um, rarely was it. Rarely do we see more than 10 degrees. All right, so rarely do we see temperatures in San Francisco varying more than 10 degrees from the mean temperature of 65 degrees. Whereas if we look at Provo, we see that there are actually quite few days, right, where the temperature is more or less than 10 degrees from the mean of 67 degrees. So again, we can see that the variation in temperatures in Provo is a lot greater than the variation in San Francisco. So we can see visually that there's more variation in temperatures in Provo, but how do we actually measure that variation? And so we can actually measure it by calculating the standard deviation. So I'll talk about that next. How do we measure the numerical value for that standard deviation? Okay, so standard deviation is a number that measures how far away a typical value is from the mean. And it basically tells us how much the data values deviate from the mean. And it measures the variability in the data set. So there's a formula for calculating that, and I'll show you the formula for calculating the sample standard deviation, and the notation we use when we have a sample is S, and then also how you would calculate that if you were looking at the population data. So for the population, the notation for the standard deviation is sigma. So to calculate the standard deviation for a sample, what you want to do is you want to take the square root of, and this formula, it makes a lot of sense. Because the standard deviation tells us how far away a typical value is from the mean, what we want to do is we want to take every single data value in our sample and calculate how far away each value is from the mean. And because it's a distance, we want to see how far away it varies from the mean, we're going to square it so that we can get a positive value. And we're going to do that again for every single value, and then we add it up. We sum it, and then we divide it by the sample size minus 1. And then once we get that, we take the square root of it. So if we're talking about the population, we're going to do the same thing. Figure out the distance between each value in our data set from the population mean, which is mu, square it, sum it up, so add it, and then divide by the population size. And then once we get that, we take the square root of the whole thing. Okay? So even though we don't have the actual data values for the temperatures for Provo and San Francisco, I can go ahead and tell you that I actually do have the standard deviation. So for Provo, I'll just write down on the bottom here, Utah, The sample mean we said was 67 degrees Fahrenheit, and the sample mean for Provo was 21 degrees Fahrenheit. And then for San Francisco, so San Fran, California, the sample mean was 65 degrees Fahrenheit, and its standard deviation is actually only 8 degrees Fahrenheit, so much smaller than the variation for Provo, Utah.